All right, so today we are going to identify some key features of graphs. We are going to do this both graphically and through looking at the function equation. So to start off, let's talk about a couple things new, the idea of a local maximum and a local minimum. So if I trace this graph up, I start at the bottom, I trace up, you'll see that we come to a maximum point right about here. Okay, and I'm going to draw a little arrow, and we're going to write local. You'll have to excuse my writing, it's with my mouse. Local max. We have a local max at this point. And we call it local because if we continue tracing up, right, and we reach our end behavior with this arrow, our graph would go on forever, all right? We would reach higher values, but we have a local max here because we have this little hill in our graph. Similarly, if I trace down, I'm going to reach what's a local minimum, as we call it. So let's draw that on our graph, local min. Okay, and same thing. If I look at my left end behavior, I'm going to go down forever. So our graph will reach smaller values of y, but I do reach a little valley at this point here. That's why we call it local. The other things that we're going to work on today are finding the zeros graphically, as well as finding the y-intercept graphically and through equations. So our zeros, if we were to work there, all right, our zeros cross our x-intercept. And I'm going to put those in green. Zeros cross our x-intercept. So they'll show up at -2, at 1, and at 3. Okay? And if we wanted to calculate those with our equation, all right, we would set our equation equal to 0. Okay, so 0 equals x plus 2, x minus 1, and x minus 3. And then we solve for each value of x that would make that equation true. And if you remember, we're going to try to cancel out these factors. So to cancel out this x plus 2 factor, I would need an x value of -2 there. And you can see that that lines up with my first x-intercept. Then I'd also have an x value of 1, positive 1, okay, associated with the second factor. You see that that lines up on my x-intercept. And finally, 0 at the x value of positive 3. Okay. Now, that covers our zeros. That should go in the zeros section of your notes. And we're also going to calculate the y-intercept today. I'm going to make that in purple. Now, the y-intercept is where we cross our y-axis. And you can see that this happens at 6 here on our graph. Now, when we cross the y-axis, it means that our x value is equal to 0, right? We're staying on this y-axis. We don't move to the right at all. We don't move to the left at all. So we can find the y-intercept. And I'm not going to spell that all the way out because, again, I'm using my mouse here. We can do that by evaluating our function at 0. So if we use our function at 0, right, when x equals 0, when we're on that axis, then we can calculate what that y-intercept is. So in this case, it'd be 0 plus 2 times 0 minus 1 times 0 minus 3. Remember, all of those factors get multiplied together. So in this case, we have 2 times -1 times -3. So our y-intercept is going to be at a positive 6, right? You got that double negative there that makes it positive. You can see that that lines up with our graph. Okay, we are going to quickly calculate a couple examples with the y-intercept. So quickly just jot this step down, pause the screen if you need it. But to calculate the y-intercept, all we do is set x equal to 0 and then evaluate. So this shows up in example 1, just like it did before, all right? If I set my x value equal to 0 and replace all my values of x here, 0 plus 2 times 0 plus 4 Okay, I'm going to get 2 times 4, which is going to be equal to 8. Our y-intercept of this function, x plus 2 times x plus 4, is equal to 8. Okay, similarly, we can calculate that when we're in standard form, right? We were working with factored form in example 1. Now we're moving to standard form in example 2. Go ahead and pause the screen if you want to try this yourself, but this is even easier. If we do our function at 0 and plug in 0 for all our values of x, we'll get 0 squared plus 4 times 0 minus 3. Okay, we evaluate all that out. 0 squared is 0. 4 times 0 is 0. And we're left with minus 3 at the end. So we get 0 plus 0 minus 3. Our y-intercept is going to be negative 3. Okay, so let's go back to another graph to finish out these notes here and explore how we find all these things graphically and through calculations one more time. First off, let's identify all of our local minimum and maximum. So if I trace my graph here from the left, okay, I realize that I reach this value right around here. Okay, I'm going to have a local minimum here. And let's make sure that we always describe it as local. Okay. Then if I continue tracing up, I reach a hill here, so I'm going to have a local maximum right about here. Local max. Continue tracing down, get another local minimum, and notice how in this example, right, there's multiple valleys. So we have multiple minimums that we're going to hit. And I continue tracing up, I reach my end behavior, I reach my arrow, so there's no more local that we need to take care of here. But moving on to zeros, if we look at our zeros, I'm going to have a 0 at negative 3. That's where I cross the x-intercept. Negative 2, negative 1, and positive 1. So if we calculate the zeros of this function, remember that we are trying to make each of these factors, x plus 3, x plus 2, x plus 1, and x minus 1, we're trying to find the value of x that will cancel them out and make them equal to 0. And you guys have gotten pretty good at flipping the sign here. So our first one would be at x equals negative 3. You see that corresponds to our graph. We'd have another one at x equals negative 2. Again, that corresponds to our graph. We'd have a third one at x equals negative 1. And finally, at x equals positive 1. And again, notice how each of these, we flipped the sign from our factor, and we created a list of zeros, or a list of x values. We're not rewriting an equation. All right, finally, to calculate our y-intercept from the graph, all we got to do is look at the graph, see where it crosses our vertical y-axis. That happens at a value of negative 6. If we wanted to calculate that from our function, we have to replace x with 0, right? That's where our 0 x value is when we're on that y-axis. So if we plug that in, we go f of 0 equals 0 plus 3 times 0 plus 2 times 0 plus 1 and times 0 minus 1. Okay, if I calculate all that out, I get 3 times 2 times 1 times negative 1, and that would give me negative 6. Notice again how that matches what we placed on our graph, right?